Hello guys, my name is Lazaro and today we're going to be doing a medium LeetCode problem. This problem is called word search. Given an M by N grid of layers called board and a string called word, return true if word exists in the grid. The word can only be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. Note, there will be some test cases with a board or a word larger than constraints to test if your solution is using pruning. So let's break this down. First off, we know we're going to be getting a board which is M by N. And since it's M by N, it means it's not going to have the same dimension. It's not going to be a square. It could be a rectangle, like in example 1. Here, this has 3 rows with 4 columns. And this grid is called board, and we're going to be given a string called word right here. And inside of this board, we're trying to see if the word exists. In this case, it does exist, because since the word is A, B, C, C, E, D, inside of this grid, there are letters that are neighboring and make up that word. So now let's get to this, second paragraph right here. It can only be constructed from letters of sequentially adjacent cells, horizontally or vertically neighboring. What that means is, let's say if I start off on A, I can only go up, down, left, or right. I cannot go diagonally. So that's what I mean by horizontally or vertically neighboring. The same letter may not be used more than once. What that means is, if I start on A and then I go down to S, I cannot go back to A. That wouldn't be allowed. I need to find another A. Then here in this note is, they're basically asking us if our solution uses pruning, which you guys will see we will use for a recursive solution. So instead of going through each and every single one of these letters and trying to find if it makes up the word, we need to be smart about it. We need to know when we should do a depth first search and when we shouldn't. And that's just to cut our recursive tree down, so prune our recursive tree. So now let's look at the examples. This is our board, and the word we're trying to find is A, B, C, C, E, D. This happens to be inside of the board, as you can see right here, A, B, C, C, E, and D. So this does exist, so we return true. Now in example 2, the word we're trying to find is C. This is also inside of the board, because as you can see right here, we have S, E, E. So we return true. Now the final example is we're trying to find the word A, B, C, B. Now A is here, and then from A we can go to B, from B we can go to C, and then from C we cannot find a B. The only B that's neighboring this C is the B to the left. But we already counted that B, we already counted that letter. So we cannot reuse it. Therefore, we return false. So now that we read the description of this problem, we looked at the examples, and we saw and we understood what they meant, let's actually get to solving this problem. So here I have the board, and here I have the word. So this is basically the first example. Something that we want to do to solve this problem is, we know that we might be able to find the word inside the board if and only if we're on a letter that just happens to be the first letter of the word. So for example, if I was iterating through this board, if I see an A, I know I might be able to locate this word. But let's say I'm iterating through this board and I'm on the letter F. I should not waste my time in trying to find the word A, B, C, C, E, D inside of the board, because it doesn't even start with the letter F. So we know we should only do this depth first approach, or we should search this board only when the letter we're on matches the first letter of the word. And that right there, it's already some pruning. Something else we want to do is, before we actually iterate through this board and trying to find the word is we have to make sure if this board has enough letters to make up the word. So what do I mean by that? Where here in the word, it only has one A, it has one B, it has two C's, it has one E, and it has one D. And that's for the word. Now for the board should have an equal amount or more than the frequency of each letter in the word. So let's go through this. The board has two A's. The board has one B. The board has two C's. The board has three E's. The board has one D. The board has two S's. And the board has one F. And I believe that's every letter in the board. Now, since we constructed this letter to frequency pairing for the board and for the word, we now have to make sure that the board has every letter in the word and its frequency is equal to or greater than. So let's start off. Currently we're looking at A. Let's check if A is inside the board. Well, we can see it's right here, so we know where it is. Now let's look at its frequency and see if it's greater than or equal to. In this case, it's greater than because it's 2. So this checks out. Now let's do the same for B. B is inside the board and has a frequency that's greater than or equal to the frequency of the word. So this checks out as well. And if we continue doing this, we notice how the board has E, it has C, and D with a greater than or equal to frequency. So all of these check out as well. And this is the first thing we want to do before we even attempt to search the board for the word. And this is another case of how we can prune our recursive tree. So now we can get into how we're going to search in this board. You know what, I'll actually leave that and I'll just create a box around this. So now we want to get into how we can search through this board. So once we're on a letter that matches the first letter of the word, let's actually start searching. So we're here on this A right now. From here we can go in those 4 directions. So we know if this has an I index of 0, and then a J index which represents the column, we know that if we're on 0, 0, we have to go in 4 directions. You have to go up, down, left, and then right. And we can do that by just changing its I index, aka the row index, and its J index, aka the column index. But since we're going to be doing this recursively, we know that once we're out of bounds, aka the row index is less than 0 or greater than the maximum row index, which is 2, for example, if we were on 3, we know we're out of bounds. And this will be the same thing for the column index. If the column index is less than 0 or greater than the maximum columns, aka greater than 3, then we know we're also out of bounds on the column section. And when that's the case, we just want to return false. We're out of bounds, there's no way we can continue. But let's say that's not the case. Let's say we go from 0, 0 to 0, 1, which is a valid row and column index. Now for this, we have to continue, so we can change that. And since we know it's only 4 directions, we can set that as a constant. So we can have those values to change our row and column index set in stone and then alterate it using that those values that we'll add or subtract. But something we also want to do is we want to change this A. Once we visit this A and now we go to B, we have to mark it somehow so we know not to return to it. So let's say once we visit the A and then we go to B, I'm going to change this A. I'm going to change it to a hashtag. That way, when I'm on B, since I can go to the left and the left is not out of bounds to be valid, I could end up on A again. And that would be a waste of time. And A just also wouldn't be valid because we can't reuse A since we have already seen it. So what I'm doing is I change A to hashtag. And if the current letter I'm on is a hashtag or a pound sign, we know to instantly return false because we have already seen that letter. Now, something else I want to check is, let's say I don't go to A. Let's say now I'm on B. Since I'm on B, that means that's going to be the second letter because I saw A. A was the first letter of the word, and now I'm on B. So currently, the word we currently have constructed is AB, and that has a length of 2. So I want to check if the value that's at the second position is equal to this B. Now, of course, indexes start with 0, 1, 2, 3, 4, and 5. So if this current string has a length of 2, let's subtract 1 and see if index 1 of the word matches the current letter we're on. In this case, it does, because since we're currently on B and the letter that's at index 1 is also B, that means that we can continue. So we can carry on and we do not have to return false. If it was the other way around, for example, if this B was a D, then since it doesn't match, we know we can instantly return false. So that's something else we can add. That's another if statement we can add to a recursive call or a recursive function. So now let's say we continued all the way through. We found A, B, C, C, E, and then D. So I'm marking all of these off with a hashtag so we know not to return to it. Now the length of this string of this word we found, this one right here, this has a length of 6. There's 6 characters in the string. And the word has also a length of 6. So we know if the length of the word we found in the board is equal to the length of the word we're trying to find, the word that got passed to us, then we can return true. And the reason we can return true is before that, when we were on D, we checked if D is equal to the position of the word. So D here, the length of this was 6. 6 minus 1 is 5. And let's see if the character at index 5 is equal to the one we're currently on. And it did check out because D is indeed the same letter in position 5. So since that checks out, we can continue. And once we continue one more time, we'll have a length of 6. And since that length of 6 is equal to the length of this word, we can just return true. And once we do that, that's pretty much all we need to solve this question. Because we have the pruning by checking if the word we're currently on is equal to the first letter of the word we got passed. So that's one pruning. The next pruning is checking if the board has the same amount or more of frequency to every letter that's needed in the word. And then we're also checking if we're out of bounds, we're overwriting, every letter and putting it as a hashtag so we know we cannot go back to it. And then we're checking if every letter we're on, if the length, if the position of that letter inside of the word are equal to each other. If they are, continue. If they're not, we return false. So I usually write the pseudocode for this, but that could take it's gonna be a lot of code. So I'm just gonna get right into it, and I'm going to talk through every single step. So let's first start off with those directions. So we know how to go horizontally and vertically. So let's create an array called directions. And inside of this, let's have tuples. 1, 0. What this represents is 1 is going to be the I index and 0 is going to be the J index. So if I'm on position 0, 0, that 1, 0 is basically to tell me to go down. Because if my position is 0, 0 at this corner right here, if it's 0, 0 right here, so I'm currently right here, if I add a 1 to the I would now go from 0 to 1. And if I add a 0 to J, I would stay on 0. So it would put me, I will go from here to here. So that's representing going down by 1. And since now you guys understand that, you will also understand what -1 and 0 is. It's basically me going up. And then 0 and 1 is me going to the right. And then 0 and -1 is me going to the left. So now that we have our directions, we now want to compare the characters and frequency of the character inside the board to the character and frequency of that character inside of the letter. And we can do this by using a hash map, or in Python it's called dictionary. So I'm going to create a dictionary for the board and one for the letter. Now I'm going to iterate over the board. So right here I'm doing the rows, and since this is a 2D array or list, I also want to do the columns. So for J in range of length of board of I. Now this is going to give me every single letter inside of the board. So now let's add it to that dictionary. I want to get the count of board at that position. Oops. There we go. And if it's not inside a dictionary already, let's just return 0. So now let's make that, let's add this character to our board dictionary or hash map, whichever you want to call it. And let's set it equal to count plus 1. So if it's not inside the dictionary, it will return 0, and doing 0 plus 1, it will add it to the dictionary with the value of 1. Now we want to do something similar for the word. So doing this, I'm basically iterating over every single character inside the word. And I'm going to do pretty much the same thing for that. But I want to do it for the letter dictionary. And then get it at letter, there we go, and make it equal to count plus 1. So if that character of the word is not inside the letter dictionary, it returns 0, and then we add it to the dictionary and do count plus 1. But if it's already in the dictionary, and let's say we've seen it twice already, it's going to return 2, and then 2 plus 1 will be 3, so it increments it by 1. Now let's actually do the comparison. So for every key and value, wow, inside of the letter dictionary, we want to first get that value inside of the board dictionary. So let's get that letter. Oops, let's get that. There we go. Here the key represents the character. So let's get the value of this character inside the board dictionary. And if it's not there, let's return -1. Now we want to check if that count of that character inside the board dictionary, check if it's less than or the current value inside the letter dictionary. So basically what this is doing that frequency comparison. And if the frequency is less than the frequency in the word, we know we cannot build out the letter. For example, let's say this C, instead of being 2, let's say it was 0. Since there's no C's in the board, we can never build out this word because we need 2 C's. So that's what this if statement is doing. If its frequency inside of the board for this specific letter of the word is less than the frequency of this character inside of the word string, then it's not possible to build out the word, and we just need to return false. And this is already one way of pruning. Next, let's build out this depth first search function. With this, we're going to want the depth, the I index, actually I'm going to call it this row to make it simpler, and the column. Now we want to do some if statements as well. If the depth is equal to the length of the word, we want to return true. I'll get back to this later and explain it. Let me write out some more code so I can go back and forth and connect it all together. Now we also want to check that out of bounds. So if row is 0 or row is greater than or equal to the length of the board, so this is checking the board if the row is out of bounds. Now let's also do the same thing for the columns. If the column is less than 0 or the column is greater than or equal to the length of board, at row, let's return false. Because if it's out of bounds, let's just return false. And the reason I'm doing greater than or equal to the length of board is because in Python, the length of this right here is going to return 3. And 3 is already out of bounds. The maximum is 0, 1, 2. So that's why I'm doing equal to. Now, something else we want to check is if we've already seen that letter. And remember, since we're converting every letter to a hashtag, we want to say if the board at that row and at that column, it's equal to a hashtag or $, or the word at that depth level does not equal the current letter we're on, then we know that there's no point to continue because we already have the wrong letter. So let's return false. Now let me get back to this. Remember that I said every time we go through this, we want to check if the character at that index for the word is equal to the current letter we're on. So this right here represents the current letter we're looking at inside the board at row and column. And word depth, since depth represents how deep we are into the word we're trying to build out, and we're going to start with 0, then we're checking if word at 0, so this was going to return A, if that's equal to the current letter we're on. So let's say row and column was 0. Well, 0, 0 of this board is going to give us A, this one right here. And since depth is 0, word of depth at the character at index depth of the word string is going to return 8. And they're equal to each other, so we continue. But if they're not equal to each other, then we know that there's something off and we can just return false. Now, once the depth is equal to the length of the word, we know to return true. And why is that? Because remember, this might be specific to Python. It might change for other programming languages. But the length of the word here is 6. But its maximum index is 5. Because remember, we start at 0. We go 0, 1, 2, 3, 4, and 5. And at 5, this if statement doesn't hit. So this does not get hit and nothing happens. We carry on and we check these. So at 5, we do this condition right here. We check if the word at index 5 is equal to the current letter we're on. And if we're on D right here, this D, which represents board row column, is going to be equal to word at the character at index 5 of the word, which it matches. D is equal to D, so we continue. And this doesn't get hit. But once we go one more time and that becomes 6, we know that we've seen every single letter and we've done every single comparison because of this if statement right here, and that everything up to then checks out. And since it's equal to 6, we know that every single character matches the word, and we can just return true using this if statement. So I hope you guys understood that. If you didn't, then pause the video and try to comprehend it and notice how it does check out and it does make perfect sense. Awesome. So now let's carry on. So now what we want to do is we want to get the letter at that position of row and column. And we want to change that letter to equal to that pound sign or hashtag. So we know that we've already seen it. Now, for every single direction we have in this directions array, directions list, what we want to do is we want to get these tuples and unpack it. So let's call this I offset, and then since we're using one column, let's call it row offset and column offset in directions. So this row offset and column offset, row offset is going to be equal to 1, column offset is going to be equal to 0. And then it's going to do that for each and every single tuple. Basically what I'm doing is I'm unpacking the tuple. Now our new row is going to equal to row plus that row offset. It's going to be the same thing for the column. Now we want to do our recursion. And we want to check if our recursion returns true. So if depth first search of depth plus 1, then we pass it the new row and the new column. If this returns true, aka if this if statement hits, then we know that we found the word and we can just return true for this function. Also, if that's not the case, let's set board of row at column. Let's set this back to letter. Because remember, we don't want to change it completely. We don't want to 100% change it and leave it changed. Because we might, if we see this A and this A at this position doesn't check out, then when we get to this other A, this A is already hashtag, even though we've never visited. So we want to change it back to what it originally was. And now let's return false. we're returning false because if this never returned true, if this never got hit, then we know that we didn't find it, and it's also equal to just false. So cool. Now we have this little pruning right here by checking the characters and frequency and comparing them. And we also have our recursive function that's going to iterate through the board. Now we want to call that function only when we see that the letter that we're currently on in the board matches the first letter of the word. So how do we do that? Well, for I, let me actually copy this. Let's iterate through the board. And if the current letter we're on is equal to the first letter of the word, then let's call that function. Let's pass it 0 for the depth, I and j for the row and column. And if that recursive function returns true, we want to return true for our function. Else, if it never returns true, we want to return false. So this is how we're iterating through the board and then checking if we find if the letter we're currently on the board matches the first letter of the word. And if it does, we do our we call a recursive function. So now let's run this code. Let's see if I made any typos. I didn't. Okay, so let's submit it. And it works through and we get 99.53%. And that's all because of the pruning. If I can move this over, as you can see, at first I got time limit exceeded. And that was without the pruning. I was doing unnecessary work. But then I started to work a little bit more, adding some pruning to the recursive tree. And I got 6,900. I brought that down to 5,000, then 47,000, and then 160. And then this 60 milliseconds was in Java. Yeah, it was in Java. So this 60 milliseconds, even though it's low, that represented only 5%. So we only got 5% for the runtime. So as you can see, for Python, 164 and then 160 is quite high. All right, so hopefully you guys enjoyed this video. If you did, leave a like and subscribe to our YouTube channel. Other than that, I do want to say that we send out advanced and beginners problems every single day on our Discord server. And then we do these videos to teach you guys how to solve it. So if that interests you, please go to the description and join our server. And finally, hopefully you guys enjoyed the video and have an amazing day. Thank you.